Let's go to question 6. Okay, so question 6. Determine whether the following integral is convergent or divergent. Evaluate if it is convergent. Show your work. So at first glance, you may think this integration, this integrand and the function or whatnot looks pretty average, you know. Let's just go ahead and actually just evaluate it. However, you're going to notice that we're integrating from 0 to 1, right? So let's draw a number line. We are integrating, let's say this is 0, this is 2. Now, as we integrate, we know that we are going to be calculating this whole area. However, the problem is there's a vertical asymptote in this function. And if we find it, well, let's go ahead and find it. 0, we would just do 3/2 on both sides. That just becomes 0. This cancels out. Alright, so technically we're just left with x minus 1. And then this gives x equal 1. So what this means is we have a vertical asymptote at x is equal to 1. So that means at the point 1, let's say this is 1, there is a vertical asymptote, meaning as we shade, at 1 it will stop and then it'll continue. So that's why this is a improper integral, and we have to determine whether or not it is convergent or divergent. And this is a type 2 improper integral. As you know, type 1, we were evaluating 1 to infinity. And now, in type 2, we're evaluating numbers. However, we are evaluating at a discontinuous point or a horizontal asymptote. In this case, it is 1. So this is a improper integral. So, now that we know that, we need to split this integral. So what we can do is, according to the properties of an integral, what we want to do is we want to split this at its vertical asymptote. So we can split this, we can say 0 to 1. And then plus the integral of 1 to 2. Let's move this down. There. And so now what we have to do is we have to do the same thing we did in improper integrals type 1, and we have to rewrite our infinity or our discontinuous point or whatever, whatnot, in this case 1 as t. So what we're going to do is let's rewrite this as the limit t approaches 1 from the left side. So this would be t now. And we'll do the same thing here. Limit as t approaches 1 from the right side. Oh, that would be 2, and this would be t. Just like so. So there we have it. Now, this is going to be our I, we'll call it I, and it is equal to this, which is our I1 plus this, which is our I2. What we want to do is we want to solve at least one of these to see whether or not we get a finite value. And if we do get a finite value, we'll know that it converges. If we get anything else, it means that it is divergent and it's going to diverge. So let's go ahead and let's solve I1. So I1, is the following. Let's copy this down. This is what I1 is. For now, what we want to do is, let's go ahead and let's just solve this integral first. Let's go ahead and just solve this first. So what we want to do is, we can use a basic u substitution. We'll let u equal to x minus 1. This means if we differentiate that, that will give us du dx. So if we rewrite this integral now, it's going to be 1 over u to the power of 2 over 3, and it would be just du. And we know that technically we can rewrite that as u to the power of negative 2 over 3 du. So if we integrate this now, u negative 2 over 3 plus 1, that would be technically negative 2 over 3 plus 3 over 3, so that would be 1 over 3. And it is over 1 over 3, and so technically we can rewrite that as 3u 1 over 3, and so that means 3x ru, which was x minus 1 over 3 plus c. However, since we are just simply, evaluating, we can leave it as u, and we can actually just go ahead and change our bounds. So this, right, this 0 and t, let's change these bounds. So this means 0 in this case, we would have u is equal to x minus 1, right? This is our u, and we would just plug in our bounds. So 0 minus 1, that gives us negative 1. And then for t, do the same thing. So let's call this one u1, u2. And so that would be t minus 1. And we know that t right now is technically 1. So it'd be 1 to the, it would be 0 technically. There. So now that we have this, let's actually go ahead and integrate using these new bounds that we just found. So it would be from negative 1 to 0. So we would have, what was our function, right? So technically it was this 2 over 3, and this would mean that we would have u as 0 would be 0, oh wait, 3, 0 to the power of 1 over 3, subtracted by 3 to the power of negative 1 over, to the power of 1 over 3, this 0, this negative 1 to the power of 1 over 3, that's gonna, since it is 1 over 3, a odd power, it's gonna be negative 1, and then this negative 1 multiplied by this, that would become positive. So this would be equal to positive 3. And so that essentially means that we get 3. And that means that it is indeed convergent, because we are able to get a finite value of it. Let's highlight this because that's important. Now we're not done just yet. We got to do I2 now. So let's go up and get I2. So this is I2. We're going to need that as well. So let's write I2. And let's paste. Now we need to change the bounds again. So this time t that would be u is equal to t minus 1. Remember, t is 1 technically, so this is technically 0. And then 2, you change that, and that would be u is equal to 2 minus 1, which is equal to just 1. So those are our new bounds. So let's rewrite that. So we would have 0 here, 1 here, and we would be integrating -2/3 du. And so now if we just integrate that, it would be 3, okay, so 3, 1, right? Because this is what we're plugging into, 3, 1 to the power of 1/3 minus 3, 0 to the power of 1/3. We know now that this is, we already know this is 0, and this is just 3. So this would leave us with 3 minus 0, and that would leave us with 3. And there we have I2 now. So we know that we had I, which is equal to I1 plus I2. So now that we have found I1, I2, 3 plus 3, and that is equal to 6, and that is our answer. So we can conclude that this integral is convergent, and it converges to 6. And there we have it for that question.